I'm not streaming. Okay, so in sine function, you can see the first letter is A. It's very just like quadratic functions. What did A do in a quadratic function? If it was positive or negative, what did it do to the parabola? That was if it was less than 1 or greater than 1, it was stretched or compressed. If A was positive or negative, what did it do? Good. It showed it whether it's up or down. If you look in this graph, A will be the vertical stretch or compression. So whether it's wide or skinny, just like a parabola, and it will have a vertical reflection, meaning opening down, if it's less than 0. So if it's a negative number. So that's exactly the same as a quadratic function. If A is negative, it's reflected down. If it's positive, it's still up. If it's a value that's less than 1, we can see if it's stretched or compressed. If it's greater than 1, we can see if it's stretched or compressed. The new thing is that the absolute value of A is the amplitude. So I just need to explain to you guys what that straight up and down symbol is around A. Absolute value means its distance from 0. So if it's a -5, it's just 5. If it's a +5, it's just 5. So you don't take the sign with A for amplitude, it's just the actual number value. Okay, so we'll look at this, Elsa. Yes, but you'll have this chart too, so you'll just interpret it. K, which you can see is inside of the square bracket, so this is different from when we look at quadratic functions. K is the horizontal stretch or compression. So if you think about sine function like an accordion, you could stretch it this way and make the cycle long, or you could compress it this way and make the cycle short. So if you had like a pendulum swinging, it could swing slowly, or you can make it go really fast, right? So K, this first number inside the square bracket, it will tell us whether the cycle is long or short. Also, it will tell us if the horizontal cycle has been reflected. And if we're looking for the period, the length of time it takes for the cycle to happen, you take 360 and just divide it by the absolute value of K. So again, if K is -5, you're going to divide by 5. If K is +5, you just divide by 5. Why do you guys think it's 360? It's a circle. So sine function, this is not going to be in the recording, but like if I'm standing here, so let's say it's a particular angle that I'm standing at. If I go 360 degrees, I'm standing at the exact same angle. So the sine function repeats typically every 360 degrees. Because if I'm at a 30-degree angle and I turn 360 degrees, I still have a 30-degree angle every single time I spin around, right? Now, if you compress that, it's going to be 365 divided by whatever you've compressed it by. It would be shorter, it'd be faster. If you stretch it, it's going to be a longer period of time. D, so that's after X there, is your shift right or left, just like H in the quadratic function. D, if it's greater than 0, is going to shift right. If it's so that's a positive, it's shifting right. If it's a negative, it's shifting left. But notice in our general equation, it's X minus D. So what will happen to that sign if I plug in a negative D value, Suhani? Yeah, and the double negative will look like a plus in the sign. This is just like in quadratic functions. It will be the opposite to the sign in the equation because it already started with a negative. So if I plugged in a positive D value, it's going to be X minus that number. If I plug in a negative D value, it's going to be X minus negative. It will be a plus. We'll see this all in a minute. And then the C value on the end is shift up or down, just like K on a quadratic function. You don't have to have this memorized. We just need to use this chart and interpret things. So we're going to use Desmos. You can just look at my screen if you want. But the first thing we're going to do is just see what happens with my A value. Okay. So I'm going to plug this into Desmos. But if you guys looked at the graph, my A value is a negative. So what do you think is going to happen to my sine function if I look at my chart for A? Cameron. Okay. Okay, so it's reflected down. The A value is 1/4. What's my amplitude going to be? Oh, no. That's going to be 1/4 because it actually is your A value here. So let me actually plug this into Desmos, and then we're going to see if we actually, let me just do first. That's just your normal graph. Okay. Actually, I think if I switch it to radian somehow, That's how it was in here. I do want to switch this to rate. I'll see if I can switch it later on. That's not what I want. Thank you. Oh, yeah. No. Oh, no. But I want it to show like 360 degrees. I'll have to change the axis later. We won't worry about that for now. Because your cycle is going to be a full 360, but they're using your standard graph. Anyways, that's your sine, your general sine function. If I put in a -1/4 sine x, look at the blue one. Okay, it might be harder to see here, but how do I know it's reflected down? Start at 0. It's probably your easiest. If you look at 0, what happened to the red initial graph from 0? Where did it go? Up. Look at the blue one now. From 0, where did it go? Down. So that's how it's reflected. Even though when you look at it, you're like, wait a minute, like it doesn't look like a parabola was either a smiley face or a frowny face. I typically just start at 0. And if I look at 0, it's going down because it was a negative A value. Now, initially, what was my amplitude? What's my A value right here? 1. So the highest and the lowest values, the difference between them was 1. What happened when I made it a quarter? What's my highest and lowest value that's going to? A quarter. So it's compressed. It got like smashed. Remember, compressed is like getting smashed. So it's a quarter, so it got compressed. So instead of it going up to 1, down to 1, up to 1, down to 1, it got smashed, and now it's going up a quarter and down. Makes sense, guys? You don't have to worry about graphing it. You just need to know how to interpret it. Okay. Any questions on that? So the negative made it go down from 0, and the quarter smashed it. So instead of a high and low of 1, it's a high and low of a quarter. This is just A. So Annie, did you have a question? Yeah. Exactly. All right, so let's look at our next value. So now what I'm going to do in problem number 2 is I'm just going to take my A value and change it to a +4. So if you guys want to sketch that graph or just remember to look like a decimus, that's fine. Actually, I can put in screenshots afterwards for our notes. What do you think is going to happen if I change my A value to a +4? The amplitude is going to be higher. What do you think the maximum minimum will be? 4. And what about the fact that it's a +4? It should go up from 0. Okay, so let's try this. No, because right now I haven't shifted the graph up or down. I left it at, it's symmetrical around the x-axis. But if I shifted it up or down, Nate, then it will actually affect the range. You'll see that in a minute. Okay, so I'm just going to go in here. I'm going to change the A value to 4. And you guys can see that it's from 0, it's going up. And now instead of the maximum and minimum being 1 and 1, it's going up to 4, down to -4. Okay. For now, because we haven't shifted it left or right or up or down. Okay. All right, let's try seeing what our other numbers do. So A value, I think you guys are set to go there. This one, I still have to figure out exactly how to change to radians on decimus. But this one, I've put in x -30. So I'm going to go back to my chart so we can see what's happening. So I have sine x -30. First of all, is that K or is that D? Because it's in my brackets. K has to be in front of X and D is is behind X. So what's the 30? Is it K or is it D? D. Okay, so look at your chart. What does D do to my sine function? Shifts it left or right? Well, it's going to shift actually the whole thing left or right. If it's a -30, did it go left or like it's D -30? Did it go left or did it go right? Down. The according part is K, which we haven't done yet. Yeah, I'm hearing all kinds of left or right. So, okay. Just 1 second, Sarah. Let me. I think I need a new battery. Okay, I'm just going to write with my finger. Sarah had in the bracket, oops. had in the bracket x minus 30, right? This started off as a negative. So if I plugged in negative 30, if it went left, that sign's actually going to switch to a plus. Because it stayed a negative, I plugged in a positive 30, so it actually is going to the right. Switch the sign when you take it out of the bracket, just like we did in quadratic functions. Okay, so this one we think should shift to the right. It's going to be a little bit harder to see here on Desmos, but we can at least see the basics here. So I'm going to do, oh, I'll change my blue one again. And because it's a repeating pattern, it's maybe hard to see, like, did it shift left or did it shift right? But you can see it shifted off of the red. Probably, Josh, what was your question? You won't really be able, like, if I switch that to a plus or to a minus, it's pretty hard to see which one actually happened. I could have you evaluate it and you guys could see what happened there, but you guys can just tell me that it shifted to the right or to the left because you won't have to graph it anyways, but you can see it shifted off of the red. Okay. Yeah, just remember to switch the sign of it. And just a reminder, the K is going to be in front of X and the D is going to be behind X. That's how we're going to know which one's which. Looking at this one, what letter is associated with the +1 on the end? C. So what's the C going to do? Shift it up or down? And Nate, this is where your question comes into play. So just 1 second. Let me show you what this one looks like. Okay, so you guys see it shifted up, right? So Nate, you know how you were asking, is the maximum minimum always going to be the same value? But let me take out the +1 for a second. If my A value is 1, what's my amplitude? What's my highest, my lowest going to be? 1. If I shift it up 1, the maximum of 1 is going to go up to what? 2. The -1, my minimum, is going to go up to what? 0. So you do have to take into account whether it shifted up or down. And look, you guys were exactly right. The minimum went from -1, shifted up to 0. The maximum was at 1, is shifted up to 2. Okay. So what if I put in a 4? What would my minimum of -1 shift to? I put in +4. If my minimum was -1 and I put in +4, it's going to shift up to 3. My maximum was 1. And if I put in +4, it's going to shift up to 5. So it's some simple algebra, but you do have to think about the amplitude and the C value on the end together. Okay. And you guys can see you're exactly right. It went up to 3 and 5. Okay. And if I shifted it down, obviously the exact same kind of math works. So +1 take away 4 is going to shift down here to -3. And the -1 take away 4 more is going to shift all the way down to -5. Okay. So you got to do a little bit of mental math or grab your calculator for that. Okay, problem number 5, last one here. Looks like that. What letter is this for? K. What does K do? Pardon? Oh, you actually will have to look. So I don't have it here. It's right here. In front of X is going to be K. And what does K do? Horizontal stretch. This is like the accordion. Okay. So let's see what happens here when I put a 4 in front of K. First of all, you could probably figure it out. What's 360 divided by 4? Closer. 90. So if it was going to repeat every 360 degrees and now it's repeating every 90 degrees, is it going to be an accordion pushed in or stretched out? It was 360 and now it's 90. So it should be like compressed like this. Let's see if Madeline's prediction is right. Let's see what happens here. I'm going to put a 4 in. Oops. Where'd that go? Why isn't it going? Hopefully that's where I'm at. Okay, let me put the 4 in the front of X. Oh, is Madeline right? Yeah. Does it look like I took the accordion and went like this or like this? Yes, exactly. So it was horizontally compressed. So think about it like an accordion. If I stretched it out, it's going to go this way. If I compress it, it's going to go that way. So what number do you think we should try if we want to see if it's an accordion stretched out like this? What should we try? -4? Let's try a fraction. So remember, it's the absolute value of k. So 4 and -4 are actually the same. So let's try a quarter. Oops, I gotta fix them for 1 second. There we go. There we go. Oh, it's like the slider. Actually, I think there is a sine function, one with a slider, if you want to play around with it. Guys, look at the purple graph. Did it get stretched like we were hoping it would? Cameron's wondering. Okay, well, let's see the length of a cycle. Let's see the length of a cycle. Actually, let me change the fraction to a less small number. Oh, that's not going to work. That's worse. Okay, we can see this one. We can see this one, I think. Okay, so here's 0, and then it goes down, and then it goes up, and then it's back to 0. So on this one, hopefully you guys can see. And if I use x as 0 as my reference point, it goes 0, down, up, 0 again. So can you see that purple cycle is that long? Oh, the cycle means the whole pattern, so it's up, down, and the up repeat. So I have to, yeah, because it goes down, up, then down again. Okay. Now the red one, if I use 0 as my reference point, my red one goes up, down, up, starts there, stops there. So it extends the. So it extended the cycle. Okay. Because what's 360 divided by a half? No. Divided by a half. A 1/8. No. So what's 360 times 2? Oh, 920.
I just put 360 divided by 1.
360 divided by half.
I like
720. So we say 920. 720. 7. Because when you divide by a fraction, it actually gets bigger. So the cycle got longer because we divided by a half. So it got stretched this way. So the red graph actually the cycle is this long. The purple one cycle is that long. It got longer. Okay. So if you're confused, grab a calculator, see what happens. Cameron, you're good? Okay. All right. What are you confused by? Yes. Grab your calculator. Okay, Madeline, it's like this. Madeline, it's like, I'm going to make the number smaller. Let's say I had 10 cookies and I split them all in half. How many pieces of cookies do I now have? 20. Okay, so if I did 360 divided by a half, then you can see over there on the side it says 720. So on.
Increases the number.
Yeah, anytime you divide by a decimal, the number is going to get more. Okay. Okay, let's try one more because we've been looking at all the letters independently. So just for fun, we're going to throw them all together because, you know, we can. Actually, I don't have a K in this one. Okay, what's your A value in this question? -2. Okay, so the negative just what? It should go down from 0. What's the 2 do?
Wait, no, wait. Hold on, let me get the notes.
Brian, what are you thinking? What's 2 do? One second. It's the amplitude. So what is stretched? Because they're stretched twice in our graph. What's stretched? Good. It makes it the range. So the highest and the lowest is stretched by 2. Okay, good. What's the plus 45 going to do? Which way? Left, 45 degrees. And what's the negative 2 going to do? Down, down. Okay, so let's see if we can do this for a second without graphing it. Just looking at my amplitude, and I want to think about my range. Okay, looking at your amplitude, what's your highest and lowest value before we move it off of 0? Positive 2 and negative 2. Everyone's with me so far? Your amplitude is positive 2, negative 2. Okay, now I'm shifting the whole graph down 2. So what's my highest and lowest value is going to be? 0 and negative 4. So let's see if it goes down. The amplitude has been stretched by 2, and the maximum is 0. The minimum is negative 4, and it's been shifted left. Let's see if we did that right. Okay. So y equals negative 2 sine x. Okay, so far so good. It is going down, and the highest and lowest is 2, positive 2 and negative 2. Now we're going to shift it. That one is harder to see, but it did shift off of 0. And now we're going to make it go down 2. Were we right? Yeah. Yeah. So it's harder to see this. You can just see it shifted off of 0. The peaks and valleys don't line up exactly right, Josh. But everything else we have right. So it goes down. Well, everything you guys have said is right. It goes down from 0. The amplitude got stretched by 2. It shifted left. That's your left. Which way is left? Left. And the highest is 0 and the lowest is negative 4. Which negative 2? It shifted. So watch what happens, camera, when I take it out. I moved it down. Yeah, you're welcome. You guys have this little chart on the end too, just to have a brief summary sheet of all of this stuff. It's not on mine, it's in your lesson workbook. If you guys look at this chart here, you have what the A value does is stretch or compression. It's your amplitude. It also will give you some clues on domain and range. Sine function is a consistent repeating pattern, like tides, like seasons. Your range will be dependent on your A value, but your domain will always be XER. So you can see in all of the categories, your domain is XER. Your range, you got to think about your A value and take into account your C value, whether it's shifted up or down. It gives you your C value is the shifting left or right. Or sorry, up or down. They did C before D. The C value is your up or down. The D value is shifting left or right. They don't have K in your little chart because K, for whatever reason, is not in this part of your textbook, but it is a concept with sine function. And if you take a university level course, they'll have K in there as well. So I've left it in there. But just know K is like the accordion, horizontal stretch or compression. I don't think it'll actually be in your textbook because they only do A, D, and C, not K. But I will put it in there on your test. Maybe it'll be an extended question, just make sure we can interpret the whole equation, okay?